Hello everyone, my name is Nidhi Gupta and it is my pleasure to welcome you to the webinar on Modernize and Optimize by Containerizing .NET Applications on AWS. Many .NET applications that are critical to daily operations may be operating on outdated version of .NET that are no longer receiving updates. So you might wonder how to upgrade and cost optimize these applications when your developers do not have access to the source code. So in this session today, as a .NET developer, you will discover how to leverage AWS products and services, as the team will demonstrate how you enhance the security of these legacy applications through modernization to containers, updating to a modern .NET framework, and running them to the latest Windows version. So let me introduce you to the speakers from AWS session for the AWS session today. Myself, Nidhi Gupta and Aditi Sharma, we are part of Global Windows Modernization Strategy team. Tom Moore, he's a Principal .NET Developer Advocate. Ashish Bhatia, he's a Senior Solution Architect. E.L. Gutkin, he's a Senior Technical Product Manager. And Runeet Vashisht, he's a Principal Solution Architect. Please be aware that we will be recording this session and we will share that recording with you soon. So you don't have to worry about recording it. And after the completion of the webinar, we will also be sending you a brief survey. So we would greatly appreciate if you can take a couple of minutes to respond to that, please. So this is the overall agenda for this 2-hour-long webinar covered by the various speakers. I would do a quick introduction on modernization of your Microsoft workload on AWS, inviting Aditi from our team to talk about a customer success story. Tom will review the challenge of keeping Windows up to date when OS goes out of support. Ashish will share the containerization option with ECS and EKS. EL will talk about how to modernize legacy application using app-to-container, followed by a demo of app-to-container for modernizing and containerizing existing application and building your CI/CD pipeline. Please note that we have a Q&A session open during the entire webinar. So feel free to post your questions in the chat and Runeet along with other speakers would answer them as we go along. And we would also use the remaining time at the end of this session to answer any unaddressed questions. So let's get started with the basics of what it means to modernize your Microsoft workload on AWS, and I would cover this session. So in the next 15 minutes, we will briefly touch upon what is modernization, talk about typical modernization journey, present to you some of the AWS tools for application and database modernization, and share with you the various programs that AWS provide to support our customers through their journey. So how do we define modernization? Modernization in the context of today's discussion is the process of transforming existing applications and infrastructure to a high-value open source or cloud-based services. And the main reason why customer needs to modernize is that it unlocks new business capabilities. It accelerates your innovation cycle. It reduces the technical debt, and more importantly, it also reduces the total cost of ownership because the customers do not have to end up paying licensing costs for commercial products. Here at AWS, we like to think of modernization as a journey that includes enterprise compute, infrastructure and architecture patterns, people and process. So it's an operational and governance paradigm shift for maximum resiliency and efficiency so businesses can innovate faster. So before we go deeper into the discussion, when we talk to our customers about Microsoft modernization, these are the kind of repeated questions that we have seen. Why should I modernize my application or database? And for some customers, they want to modernize, but ask, how do I go about starting the modernization? Do you have tools that can help me modernize my workload? Which modernization pathway should I choose? And should I move to open source and so on? So these are the kind of typical questions that we get asked repeatedly. So from AWS perspective, to help enable our customers, we have the right programs, the right products, and the right people to help customers unblock their challenges and help them accelerate their transformation to open source and cloud-based services. So let's talk about some of these key challenges our customers face. The first one is a pressure to innovate. So what we are actually seeing is that our customer wants to deliver feature much more faster, and they want to accelerate their innovation, especially in the challenging times, such as the case of global pandemic, where customers and all the businesses were moving to digital. Rising and unpredictable cost of licensing software is another key reason. As you may already know, IT organizations faced increased pressure to do more with less, and they have legacy infrastructure and application that were actually created as monolithic application based on old guard technologies. And some of these kind of technologies were not built with cloud in mind. So these customers are facing challenges to scale their businesses, and they're looking at ways to modernize their application to cloud-based services. Obviously, there are also other reasons like technical debt and also making sure that the staff has the right skill set to do modernization. So these challenges, such as increasing cost, agility to scale, and maintaining security and operational resiliency, can be resolved by modernizing apps and database to AWS. Now let's see how our customers can take full advantage of the cloud. So there are three main transformations that takes place as customers look to modernize both their legacy Windows application and databases. The first one is the moving the infrastructure from on-premise to cloud infrastructure. This is often referred to as lift and shift or rehosting. So it's simply migrating existing application and database to a cloud server instance. There is no need for code changes, and the customer manages the instance configuration, software images, etc. Now, once you are in a cloud environment, the next transformation is around replatforming the application and database into a more automated and managed environment. From an application perspective, that means moving from virtual machines to containers. And containerizing application will help you develop, maintain, and deploy application faster and improve portability. AWS has tools like App2Container to help automate the process of containerizing legacy application. We will discuss more on that in the later presentations. On the database side, moving from a self-service model to a managed database service like RDS SQL will eliminate the need to do activities such as provisioning, patching, and backups. So ultimately freeing up your resources for more value-added activities. The third area of the transformation to the very right is moving from commercial software licensing to open source. Many traditional commercial software vendors have built their businesses around software licensing agreements that are aimed at locking in customers and using punitive licensing terms to force upgrades and migration. And oftentimes, commercial software licensing fees typically add 20 to 50% of cost on top of equivalent open source options. So refactoring your application and database to take advantage of open source options can not only help you lower your cost, but improve performance and gain access to the latest innovations. So these three areas of transformation can be done progressively in stages or all at once, depending on the application and databases and your overall readiness to modernize. So to summarize, a migration and modernization are both important to maximize the benefits of the cloud. Both have significant benefits, including cost saving, improved agility, resiliency, and scalability. In addition, modernization optimizes your application and workload for the cloud by replatforming using AWS cloud-based and managed services or refactoring to build them for the cloud. These services handle the heavy lifting of infrastructure, allowing you to focus on your core business logic, workflows, and data. We recognize that modernization is a journey, and it may vary from one customer to another. At AWS, we help customers wherever they are in their journey, oftentimes by incorporating multiple types of modernization pathways and providing tools, services, programs to meet your needs in helping to accelerate your journey. In this graph, you see x-axis is a timeline, and y-axis is the cost of compute shown by the yellow line, and innovation velocity by the bluish line. So from our customer data, we have typically seen at least 20% of unit saving in unit cost of CPU cycle with just a lift and shift migration to cloud. And as the customer continues to optimize their cloud instance through right sizing, license optimization, and selecting the best pricing model for their usage behavior, they typically see an additional 10 to 20% saving. And by adopting higher level modernization approaches and services, moving into a cloud-based services, customer experience further cost saving, which may be saving of 60% or more. And all of these cost saving can then be redirected or reinvested by the customers into driving more innovation and value-added activities. Now let's talk about how we go through this modernization journey. And when customers actually think of modernizing their application and database, they think about modernization from the perspective of these three phases: the assess, mobilize, and modernize phase. So typically customers start with assessment phase where they do a discovery that try to understand what application exists and then figure out what is the business case motivation for them to get started with the modernization project. The assess phase is the beginning of your journey and sets the foundation for a well-planned and executed modernization project. We provide discovery and business case tool free of charge for our customers during this phase to get the project launched. After the assess phase, you progress to the mobilize phase, which builds capabilities to operate modernized solution in the cloud. And the focus is on developing a landing zone, operational readiness, cloud skills, a strong project plan, and a compelling business case for modernization. So the mobilize phase prepares you for the modernize phase, where you execute large-scale modernization and cloud operations. After completing the mobilize phase, modernization work can proceed rapidly and efficiently during the last phase, since it builds on the established foundational capabilities where you would do replatforming or refactoring of your application and databases. So each successive stage completed establishes a full-scale cloud operating model, and there are several AWS tools and services available for our customers to accelerate the modernization at every stage. And we will discuss that in the upcoming slide. So AWS offers several tools to expedite your modernization journey. In this slide, I'm showing you some of the tools for application modernization. I'll not go deeper in this session as much because all these tools are covered usually in our different webinars, and today's focus would be more on app to container. But just to give you a summary, in the assess phase, we have a migration hub strategy recommendation that provides assessment of your application portfolio in an automated manner. And using this tool, you can get recommendation on your modernization pathways. In the modernization stage, we have porting assistance for .NET that helps refactor the old .NET implementation to the latest .NET core. We have app to container that we will discuss later. And if you want to transform monolithic application into microservices, you can use microservice extractor for .NET or AWS toolkit for .NET refactoring to do the complete app transformation. For all these various tools for deep dive, please check out our other webinars that we host on a regular basis, or you can check out the previous webinar recordings. Our focus today is more on the application modernization, but I'll briefly touch upon the tools that we have for database stack modernization. So in the assess phase, we have database migration service and schema conversion tool. And in the modernize phase, we have tools such as replatforming assistant and Babelfish for Amazon Aurora. So AWS has created a number of offerings to support your modernization journey to help you go through these modernization projects. And when we speak with our customers to understand their modernization needs, typically we have identified 3 different scenarios. The first scenario, which is listed on the far right, is where the customer know how to do modernization, and they also have the staff to do modernization project. So pretty much they are self-sufficient in undertaking these projects. And these customers typically need some sort of motivation factor to kickstart their project. We enable these customers looking to offset some of their project costs to accelerate decision making. The second scenario in the middle is where the customers know how to go about with the modernization, but they may not have people or staff to do the project. So they would need some sort of expert guidance, whether it is in the form of ProServe or partners to actually execute on their modernization project. And the third scenario is where customers want to modernize their application and database to move to modern technology stack, but they do not know how to do modernization. They do not know how to go about approaching this, and they do not even have people to do that work. So they need some sort of a coaching methodology to train them on how to modernize their application such that they can become self-sufficient and modernize on their own. So from AWS standpoint, whether you benefit from expert guidance through partners or ProServe, or you need resource supplementation for putting together a business and technical justification and a plan of action, or if you're looking to offset some of your project costs, we are here to help. As I mentioned, we have some of the competency partners that AWS work with to help customers make decision to move to cloud. And this shows some of the competency partners for Microsoft Workload. So let me now invite my colleague Aditi Sharma and to go through some of the case studies where the customer has seen success with modernization. So welcome, Aditi.
Thanks, Nidhi.
So what are we seeing in the market from a modernization perspective, and are our customers ready for modernization?
Yes, absolutely, Nidhi, and thank you for inviting me to speak today. We're absolutely seeing a vast number of our customers are moving from Windows onto our modern services and modernizing their applications and databases on open source AWS cloud native technologies, right? Like you covered, Nidhi, modernization is a journey, right? And all of our customers are at different points in their journey. All of them have different drivers. You mentioned cost reduction. You mentioned increased innovation velocity and agility. You mentioned capturing larger segments and scalability. So all of those are different drivers that our customers are using or driven by to modernize, right? And all of these customers are also across a variety of industries and geographies, and they've all chosen different pathways to modernize. Again, something that you've covered, and we're going to dive deeper into the containerization pathway. But bottom line is they've really achieved all of their business outcomes through modernizing on AWS. So we're definitely seeing that as a market trend right now.
So can you tell us a story where the customer was able to achieve their business objective via modernization, please?
Yeah, I actually have a really impressive one to share with you. This is one where we helped DraftKings modernize their .NET legacy applications, right? And this is a really good story for a variety of different reasons. It's a story of how modernization on AWS enabled them to go through a merger and meet their increasing customer demand, all during a global pandemic. So some of you may know that DraftKings went through a merger with SB Tech in early 2020, which was right at the beginning of the pandemic. They became the only vertically integrated pure play sports betting and online gaming company. With the merger, as you can imagine, they needed to integrate their software, their platform, their people. It required more than just code changes, right, to turn this into an enterprise solution. That's when they decided to really dive deep and embark on an intentional plan and a step-by-step approach to a technology upgrade via modernization on AWS.
This is a very interesting use case, Aditi. Can you tell us more about what modernization pathway did DraftKings adopt?
Yeah, and we've talked about it earlier as well, right? There's multiple pathways the customers can choose, whether it's database or applications, like I was saying, containerization, refactoring, breaking up monoliths. In the case of DraftKings, they really quickly identified their starting point as the core technologies underlying pretty much all of their microservices, which was .NET Framework and Service Kit at that point. They decided that they wanted all their services to be converted to modern .NET, which could be cross-platform, right? It had the technological benefits of better efficiency, more efficient DevOps and so on. But more importantly, it opened up a lot of options for them. They could run on Linux, they could run on containers, they could run on Kubernetes. So that's the pathway they chose.
So what was the scale of this conversion to .NET Core, and how was DraftKings able to successfully modernize in such a short period of time?
Yeah, so they actually modernized hundreds of their applications from .NET Framework to modern .NET. And they did this very quickly and efficiently, and they did this within a span of a year, if I remember correctly. And they followed a very systematic approach for their modernization project, where they first off started with seeking supportive leadership. They had a very strong business case. Once they had the leadership support, many teams across the entire engineering organization wanted to know the benefits. They wanted to know, why is it good for them technologically? What are the business benefits? How can they contribute, and so on and so forth, right? So they really had the entire organization behind this effort. And once the project was kicked off, they followed the agile methodology. They broke up larger tasks into smaller functions. They managed their backlog. They kept the migration scope under control. And the most important factor in terms of them achieving this quickly and at scale was the fact that they created automation that could do 90% of the work for converting the microservice to modern .NET. So that really achieved them or helped them achieve this scale. Of course, they tested extensively along the way and pivoted in response to lessons that they learned and so on and so forth. But really, it's fairly clear from the story that in order to be successful at scale during your modernization journey, it's imperative to build a clear path to modernization with a direction and philosophy. You can't just define a few steps and expect to be successful, at such scale. So overall, a really impressive success story, and something that our customers that are looking to follow a similar path can certainly learn from.
Thanks for sharing, Aditi. This is such a great story of how our customer identified a business need to modernize, took the challenge head on, and were very quickly able to achieve their desired business outcomes. So have you encountered any scenario where the customers would like to modernize, but there are significant blockers that prevented them from embarking on their modernization journey?
Yeah, absolutely, Nidhi. In fact, it's more often than you think. Many of our customers who want to modernize don't know where to start, right, or how to start. Sometimes, they're not able to identify good candidates for modernization. Those are some of the questions you brought up earlier in the presentation as well. oftentimes they don't have the resources skilled in cloud native technologies, and sometimes they're just simply too busy to spare any resources for modernization. So all of these are scenarios where we can help our customers, and specifically when they need resource support, that's where our ProServe and partners come to our rescue. And we have really great modernization stories with both ProServe and partners, but I want to dive into one such story with our advanced consulting partner named Cloya, and how they helped our customer EPOS Now modernize their Windows environment on AWS.
So good to hear that we are able to work backward from our customers' needs and team up with our partners to help them meet their objectives. So can you tell me a bit more about the scenario at EPOS Now that you mentioned, and how we work with Cloya to help them modernize?
Yeah, so EPOS Now is a point of sale software where more than 30,000 restaurants and retail businesses are using that to run their business every day. They're leading provider of POS software for retail and hospitality. They help organizations manage sort of their end-to-end spectrum of services like sales, inventory, reporting, CRM, pretty much the breadth of services. So EPOS Now had been running their Windows-based API environment on AWS for quite some time, and very successfully, right? However, the company needed to scale rapidly to meet their rising customer demand. And they had a monolithic .NET Framework API that was running on EC2 Windows. It was slow to scale, and it was challenging to manage because it wasn't built with the modern tools designed for the cloud. So that's where Cloya stepped in. They partnered up with EPOS Now, to move their .NET Framework to modern .NET, and from Windows to Linux. They helped decouple their API into a microservices architecture that runs on Kubernetes clusters. We're going to talk more about the containerization pathway in just a few minutes. They also deployed Lambda along with Amazon API Gateway, which could kind of help them create their APIs much more easily and maintain and secure their APIs going forward. So as a result of all of this joint effort between Cloya and EPOS Now, they can roll out software features in a day instead of 3 weeks earlier, and they're able to scale more easily to accommodate their international expansion. So all in all, it was really a great partnership between Cloya and EPOS Now to completely revamp their architecture on AWS, and it helped them realize their benefits of cloud native technologies. So again, a really good story for our customers to learn from.
Absolutely, Aditi. Thank you for sharing this. Definitely a big win for EPOS Now, Cloya, and AWS as we team together for their success on modernization. So thank you so much for sharing that with us today, Aditi. And now I will pass it on to dive a little bit deeper into the topic by passing it to Tom Moore for covering the Windows Update Challenge. So here you go, Tom.
Thank you. Alrighty. Hi, everybody. My name is Tom Moore, and I'm a .NET developer advocate here at AWS, which basically means I have the best job in the world because I get to spend my days talking to developers about how to run their .NET applications on AWS. Now, this session is called the Windows Update Challenge. In this session, we're going to talk about why Windows upgrades can be challenging. We're then going to talk about how containers can help overcome some of these challenges. Then, once you've adopted containers, how does this affect your upgrade path, both for your hosts and for your applications? And then we'll finish up with what do you do with the other applications? Those don't really fit nicely into buckets. So what is the Windows Update Challenge? No, this isn't the latest social media thing. What it is that Microsoft brings out a new server-based operating system every 2 to 3 years. Now, these operating systems typically have a support life of about 10 years. Once these operating systems do go end of support, the customer is forced to make some hard decisions. You can pay for extended support, and Microsoft will happily sell this to you. However, it does get expensive, and the extended support is normally purchased through an enterprise agreement, so you probably have to be carrying active software assurance on those instances that you want to get extended support for. Now, those costs really start to add up. Additionally, buying extended support doesn't really fix the core problem. It really just kicks the can a little bit further down the road. You can force an upgrade project. However, this is very expensive from a time perspective. I mean, we all have day jobs, right? And if that server hasn't been upgraded in the last 10 years, what are the chances it's going to be a smooth upgrade? These upgrade projects are time consuming and risky from a project perspective. It can really burn a lot of time as you try to get a bunch of servers to fast forward 10 years. Even if things do go smoothly with the upgrade projects, you typically get done just in time to start over with the next new operating system. Or finally, you can cross your fingers, hope for the best, try to limit your blast radius if something goes wrong, and go unsupported. Now, if you're a customer in a highly regulated environment, this causes huge problems. It's also a security nightmare because these systems aren't getting exploits patched. So how bad can that be, right? Well, I did a quick search and I managed to find that Windows Server 2008 has 2,486 vulnerabilities. Windows Server 2012 has 2,352 vulnerabilities. Now, the issue really isn't the number of vulnerabilities here. All operating systems have vulnerabilities, they get patched, life goes on. The issue is that when these operating systems stop getting security updates. Now, Windows Server 2008 went end of life in 2020. So that's nearly 3 years with no security updates. And Windows Server 2012 goes end of support this year. Now, before I was a developer advocate, I worked as a Microsoft Specialist Solutions Architect. One of the things we did for customers was to perform something called an Optimization and Licensing Assessment, or an OLA. Now, I'm not going to go too deep into the details here, but an OLA gives you some really valuable information. The assessment scans through your entire IT estate, figures out the best way to move your servers to AWS, tells you about the right sizing and things of that nature. However, it also helps uncover some of the skeletons in the closet. What's that server? What does it do? Nobody knows. Typically, at the end of an OLA, we sit down and we talk to the customer about the data that's been uncovered. We'll say, hey, you know what? We found 3,000 servers, 2,000 of which are Windows. Now, this may or may not be a surprise to some customers. I've had some customers to say, yep, sounds about right. And I've had other customers who are generally surprised at the number of servers that they have. And with Windows Data Center virtualization and oversubscription, this number of servers really isn't that uncommon for mid-sized organizations. But then we point out that all of this is not supported by Microsoft any longer. And this is where the surprise kicks in, and sometimes a little bit of panic, because based on this list, the customer probably thought Windows Server 2019 was their standard. Now the customer has to go and figure out what those servers are, who owns them, and why they haven't been upgraded. Now, okay, in this case, it's only 160 servers, but that still could be a fair amount of work. So how does an organization get into this situation? Well, we see a lot of one-to-one server to application deployments. So we deploy this app to this server, and that's it. And customers accomplish this by oversubscribing CPU and memory. So you may have 32 cores on a box, and you may have 120 gig of RAM, but your virtualization may be dishing out 2 to 3 times that amount of resources to your virtual servers. Why? Well, it's something we call noisy neighbor syndrome. So you have an application that gets really, really busy and consumes all the resources on a server. And the other applications get starved for resources. Now, this one-to-one deployment, application to server helps mitigate this somewhat, but not entirely, because a really busy server can still overconsume resources and create noisy neighbor syndrome in the pool of resources that they have allocated to them, but it does help. However, it leads to the upgrade challenge. because the sheer number of servers that are running in the organization creates a huge amount of work to upgrade. The good news is containerization does help with this issue. Containerization helps us mitigate both noisy neighbor syndrome and the sprawl of upgrades. So by deploying containers, we can set per container limits on CPU and memory usage. This caps the resources that an individual container can consume per instance. Now, of course, we want our applications to be able to scale with demand, so we can use auto scaling to create more instances of a particular container as needed. However, we can limit the upper number of instances that can be created. So we can ensure that no particular application can consume too many resources and starve the other applications. This prevents noisy neighbor syndrome and helps reduce the number of servers that we need in order to support our applications. So we no longer need one server per application or 2 servers if we want redundancy and high availability. Obviously, when you adopt containers, you still do have to perform upgrades. However, the process becomes a lot easier because you have a lot less servers to upgrade. The first part of your process is going to be to upgrade your hosts. These are the servers that underpin your containers. Now in this image, we're running 36 container instances, but we're only using 6 servers. With a one-to-one deployment method on premises, we would actually have 42 servers to upgrade between the hosts and the virtual servers. In this case, so we've got 6 servers, we've only got 6 that we need to do the upgrades on. Now the good news is in most cases, there's some automation that can help you with the host upgrades. If you're running everything on a cluster of self-managed EC2 instances, then you can use Systems Manager to upgrade the operating system for you. If your instances are part of an auto-scaling group, then you can update the underlying AMI and use auto-scaling to replace those instances. If you're using something like Elastic Container Service, ECS, or Elastic Kubernetes Service, EKS, then those services can help you with the automation there. And finally, if you're using a service like AWS Fargate or AppRunner, you don't have any servers to worry about anyway. Now, Ashish is going to talk to you about those services in detail in the next section. For now, just understand that they make your life easier from an upgrade perspective. Now, once your hosts are upgraded, you go about upgrading all of your applications. So normally, if you're running containers at scale, you're probably going to deploy them through a CI/CD process, so continuous integration, continuous delivery process. This allows us to have control over the configuration. Based on this, you upgrade your Docker file, you push the changes to your source control system, and then your applications get updated by your automation. Now in this slide, we're showing a blue-green deployment, but you can still use any deployment method that you prefer. The main thing is the updates are streamlined, so you aren't spending months going through an upgrade process to countless servers. Now, of course, you still do have to test the applications as they get rolled out, and if there's a regression caused by updating the base container, you need to roll back. However, that's usually and hopefully going to be a case of managed by exception. So what about the other applications? And by other applications, I mean the applications that maybe you don't have the source control for, source code for. Maybe a developer left the organization, or maybe you had a third party that wrote them, and that third party may or may not be around any longer. Or, and this is probably the most common situation, you simply don't have the budget, be it time or money, or both, to effectively upgrade the application. In order to help with these kinds of issues, and really to containerize at scale, we've created a tool called App to Container. With this tool, you can build containers from running applications and deploy them into AWS. This tool is going to be part of the presentation in the second half. Now, one final thing before I pass on to Ashish. If you're a developer building .NET applications on AWS, we really want to hear from you. Your feedback is critical to our products and our developments. I regularly conduct one-on-one meetings with customers to understand what's working, what could be better from a .NET developer perspective. So if you can spare an hour to talk to us, we'd really value your feedback. Drop me an email at moretom, it's my name backwards, at amazon.com, and I'll set up a call with you and some of our product teams. With that, I'm going to hand off to Ashish to talk about container services.
Thanks, Tom. Hello, everyone. My name is Ashish Bhatia. I am a senior solution architect at AWS, and my primary focus is modernizing .NET workloads. And this requires working with a different set of customers, helping them modernizing their .NET stack as they look to migrate and modernize on AWS. So here is the agenda for this section. We're going to start off with talking about some of the key decision points when containerizing .NET applications. Specifically, we're going to talk about the operating system and the base image selection. Then we're going to talk about the AWS container services. AWS offers several container orchestration services that can be used to run .NET workloads. We are going to review different compute options as well as orchestration engines available on the AWS platform. And then we're going to finish up with talking about challenges when containerizing .NET applications, some of the common patterns or issues that we have seen in the field, and what is AWS prescriptive guidance around those topics. Now, one of the first choices you need to make when containerizing a .NET application is which base operating system should I use? As you can see on the slide, if your app is built using .NET Framework 4.8 or earlier, the only option is to run them as a Windows container. However, if your app is taking advantage of the newer version of .NET or .NET Core, what Microsoft used to call, you can choose either a Windows container or run as a Linux-based container. Now, the natural question is, why should I care? Now, there are two key factors to consider when you're actually making the decision. First, the underlying operating system does impact the startup time for deployments. Windows container images are larger compared to Linux, and they can range anywhere from 3.8 to 5 gigabytes. Now, this does increase the startup time for a Windows container host, especially when the image that will be hosted has never been run before. And second is the cost aspect. So when we talk to our customers, a large number of them are packaging their .NET applications as Linux container. And this may involve a two-step process. If they're actually running an application on a .NET framework, they do take advantage of the porting assistant tool that Nidhi showed earlier to convert their .NET framework app to .NET Core and then package it as a Linux container on AWS. Now let's review what is driving this adoption from a customer base. The first big reason is the cost savings. By running your application or .NET apps as a Linux container, customers can get rid of Windows licensing cost. Now, for some of the larger environments, this cost can be substantial. The second aspect, .NET or .NET Core is a future, and running apps as a Linux container gives you the option to access the innovation from the open source community. Furthermore, customers can reduce their total cost of ownership to run these .NET apps on AWS platform by running them on an ARM-based instance. AWS Graviton instances are designed to run on ARM-based compute, and they have been in production since November 2018. Currently, we are actually on the third generation of the Graviton instance, which was released on May 2022. And 48 of the 450 of our large customers are leveraging Graviton. So the point to note here is Graviton has been out there for a while. .NET Core is well optimized to run Graviton too. Now here is an example of running a sample .NET workload across different instance type on AWS. For folks that are new to AWS, we actually have different kinds of instances that you can take advantage of on the AWS side. So right here, we are actually running on M, R, and C. a sample workload across these three instance types. The orange is depicted as Windows, the blue is actually for Linux, and green is for Graviton. And as you can see, the cost savings are significant when running the .NET workloads on Linux. In addition, you can realize further cost savings by running the same app and taking advantage of the Graviton instances that AWS offer. So key takeaway here on this slide, organizations can reduce their TCO by hosting .NET apps and containers on Graviton-based instances. And the savings can be substantial. Again, it will depend on the workload that you're running, but for a sample workload, the savings are substantial here. Now let's review the container services that are available in AWS to run your .NET workloads. AWS provides a range of container services that can be used to run your containerized workloads. Now, to store container images, AWS offers Elastic Container Registry, and there are two flavors available. The first is a private, which is listed here, and you can also have a public gallery to store and share your images. For container orchestration, AWS customers have a choice of 4 services. You have ECS, or Elastic Container Service. We have EKS, which is Elastic Kubernetes Service. We have AWS App Runner and Red Hat OpenShift on AWS. We are going to talk in more detail about the 2 most popular orchestration engines, and those are Elastic Container Service and Elastic Kubernetes Service. Now, when the choice comes to compute, you actually get 2 options. You have EC2, which is basically a virtual machine running on the AWS platform, or you actually have an option of running it as a serverless, which is called Fargate. And we're going to talk about Fargate in more detail in further slides. Now, for networking, you actually have 2 options. You have Cloud Map and App Mesh. Both these services come into play for architecture that involve a large number of services. Cloud Map acts as a service registry, and it basically facilitates service lookup with AWS DNS service called Route 53. And App Mesh is more suitable for service traffic within your internal trust boundary. So now let's talk about the orchestration engine that is Elastic Container Service. It is a managed service, and it basically provides a platform for deploying, running, and managing your Docker container. So let's say you actually have a .NET app, you were able to Dockerize it. In terms of the orchestration engine, you can select Amazon Elastic Container Service. Now, here are a few reasons why you might choose ECS. Firstly, it's a fully managed service. And what does that mean? It means that AWS will take care of the underlying infrastructure, security, and maintenance of the orchestration platform. And you, as a developer or as a DevOps person, you can focus on your application rather than the infrastructure. It has pre-baked integration with other AWS services. So if you take a look at the bottom part of the slide, these are the other AWS services which Elastic Container Service already has pre-built integration. For example, from a load balancer, it already actually has integration with ALB. For dynamic scaling, you can take advantage of auto scaling group. For security, we have IAM, which stands for Identity and Access Permissions. And similarly, other services have deep integration here. It is highly scalable. It is designed to scale to meet the needs of your growing applications. It can support thousands of containers running on multiple EC2 instances. We have well-documented case studies where customers are running their .NET workloads on taking advantage of ECS orchestration. Now, with ECS, you do get an option to run your containers or .NET containers using a Fargate, which is a serverless compute option for containers, which eliminates the need to provision and manage servers. And we're going to talk about that in further slide 2. So overall, Elastic Container Service is a powerful and flexible platform for deploying and managing or running your .NET workloads in the cloud. It can be a good choice if you're already using other AWS services and want to integrate with containerized applications with your existing infrastructure. Now let's talk about Elastic Kubernetes Service. It is a fully managed Kubernetes service that makes it easier to run your .NET workloads on Kubernetes. Now, here are a few reasons why you might choose EKS. With EKS, AWS takes care of the underlying infrastructure, security, and maintenance of the Kubernetes control plane. And this allows you as an organization to focus on your application rather than setting up the control plane and the infrastructure. So it is basically a fully managed service. It is highly scalable, and it is designed to scale easily to meet the needs of your growing application. Like ECS, it can scale to support thousands of nodes and tens of thousands of containers. It does integrate well with other AWS services such as Elastic Load Balancing, Amazon EC2, and Amazon VPC, allowing you to take the full advantage of breadth of AWS services to build your application. For the EKS, you also get hybrid deployment, where you can run your Kubernetes workloads both on the cloud and on-prem. So to summarize, both EKS and ECS provide features for managing containerized applications at scale, but they differ in their underlying technology and approach to orchestration. EKS is using Kubernetes, which is widely used and popular container orchestration platform, while ECS provides an orchestration platform that is designed specifically for AWS. Now, one of the common questions that gets asked from a customer, which orchestration service should I use? Is it EKS, ECS, or the other ones? The choice between EKS and ECS depends on your specific requirements and use case. If you're already using Kubernetes and want to take advantage of its features, I will say EKS is a good choice. If you prefer something simpler and more streamlined orchestration service that is tightly integrated with AWS, ECS might be a better fit. But the key to note here is for a .NET workload, you can run on either one of them. So now let's talk about the serverless container. Now, AWS Fargate is a serverless container platform that allows you to run containers without having to manage the underlying server. So it basically frees you from the operational burden of managing virtual machines and provide flexibility to scale. It gives you an option to pay only for what you use. So this becomes extremely powerful for an event-driven application, where as the event comes in, the orchestration platform can spin up your workload as a Fargate container, run that business logic, and once it's done, it can spin it down. From CI/CD perspective and DevOps perspective, with Fargate, you no longer have to provision, configure, or scale clusters of virtual machine to run containers. And it basically frees you up to figuring out the right server type, deciding when to scale your clusters, or optimize cluster packaging. Now, if you have a Windows container, you can still run it as a Fargate on ECS platform. Now, earlier I talked about a decision point that you need to make when containerizing a .NET application. Now, there may be scenarios where you're not able to port your .NET application to .NET Core and run it as a Linux container, and you're basically running it as a Windows container. Now, Windows container images are large, ranging from 3.5 to 5 gigs, depending on the version that you're selecting. Now, one of the biggest challenges with a larger image size is it does increase the startup time for a Windows container host, and especially when the image they'll be hosting has never been run before. Now, in a high pressure container environment where your EC2 auto scaling is frequently triggered to add more capacity in the cluster, this time could range anywhere from 4 to 8 minutes for a container to become ready. Now, this can cause service degradation and loss of revenue depending on the application business context. Now, to solve this, it is essential to implement a right strategy to avoid delays during task launch. Now, the startup time for a new container actually can be broken down into two pieces. First is to pull the image from a repo. So earlier we talked about storing your images into Elastic Container Registry. So when a new instance comes in the picture to serve your traffic, it needs to download that image. And the second aspect is to extract that image. From our testing, we have seen that pulling the image from the repo is not an expensive operation for the operating system. However, the extraction process may take minutes depending on the size and the number of layers an image contains. So how do we go about solving this issue? A common strategy that we have seen our customers take advantage of is to pre-populate their container images on the Amazon machine image, which stands for AMI. And once you have that, then the two expensive Docker operations, that is downloading your image and extracting the image, can be done during the creation of the AMI. So that way, the AMI is already ready, and when the auto scaling triggers in to dynamically scale your workload, you do not have to take that expensive hit since the image is already there. One of the common requirements we hear from our customers is my container workloads needs persistent storage, and how do I achieve this functionality on AWS? Since containers by itself are ephemeral or transient in nature. AWS offers several services like Elastic File System or EFS or FSX for Windows to achieve this objective. We have seen a great adoption of FSX for Windows by our .NET customers. FSX for Windows is a fully managed service that provides Windows file share that can be accessed over the SMB protocol. It is designed specifically for Windows workloads that require native support for Windows file system and Active Directory integration. Both are orchestration engines, that is ECS and EKS, does support integration with FSX for Windows. And you can actually use this persistent storage. With ECS, you can actually create a task definition that specifies the mount point for your storage. And with EKS, you have to provide persistent claim. We do have a workshop that explains these steps in more detail on how you can take a .NET application and take advantage of the persistent storage for both ECS and EKS. And I will paste that in the chat window of our meeting. All right, now I would like to hand it over to Eel, who's actually going to walk us through on how we can take a Windows workload and run it through app to container.
Thank you, Ashish. Hi, everybody. My name is Eyal Gutkind, and I am the PMT for App to Container. Let me walk you through my agenda and my benefits, and the benefits of listening to this presentation and the demo that will come along with it. So let's see what are the benefits of Windows containers, how we can get the benefits of containerizing our application and increasing our scale and making it more efficient. We'll touch on how App to Container looks like and what it does. We'll go through a typical AWS modernization journey that is helped by App to Container. We'll actually go into details on the App to Container workflows and how we actually get from a host, whatever it is, into an actual containerized application. I'll briefly talk on the best practices of modernizing an application with App to Container, and I will invest the majority of my time in showing you a demo. So the goal of modernizing your application is to save cost and get some beneficial operational advantages. Using Windows containers actually help you to create the same development environment that you have while maintaining a little bit of a different type of a production system. You're going to still be in the actual Windows realm, but you're going to actually deploy your applications into Kubernetes or ECS cluster with the underlying host of Windows. The deployment piece of your applications change from a single server to a dynamic optimized resource pool. So you actually have the agility to move and scale easier than running on a simple VM. You can optimize your operations and how operators actually deploy applications and build with tools that really are proven to use a cloud operation system. And you can actually create a very similar development and production system that looks exactly the same without incurring the cost of double sizing your infrastructure. And with using the right tooling to build and operate, we know it's crucial. AWS and our partners created tools and provide access to tools to help you build, deploy, monitor, and scale the infrastructure that you need for your application. Portability, let your application run on any platform, any region, and in any orchestration system with limited or actually no changes to the application itself. You can move your application between orchestration systems like ECS and others, or EKS, and deploy with a single server on your developer machine, and actually at scale of hundreds or thousands of pods anywhere else. And there is no need to change anything in the application code. And then we will show how this capability of moving containers easily in our demo. So what is apt2container? apt2container is a command line tool that interacts with the user to perform containerization operations. You do not need any access, or you don't actually need the source code to modernize your application. All you need is a working application binaries to start the actual modernization. apt2container allow you to create as many containers as you'd like, as long as you're using the application that are supported by apt2container, and those are .NET and Java application. There are no limits to the number of applications or applications that you could put on the server that can be containerized. So if you have a server with hundreds of applications or web apps on it, apt2container will go and containerize them. apt2container will create a container for each one of your applications or web app that you have on the server. apt2container will also provide you with the deployment packages and templates, so you can use that to deploy the application into ECS, EKS, UpRunner, and with Fargate. And we'll do more than that. It actually create the container for you and put the container into ECR. So from a lift of information or knowledge that you have to have in order to actually deploy your application into containers, you need minimal to knowledge, and we'll show how you do it with apt2container. As a user, you need to make sure that any effort are not needed. You don't need any effort from the developer perspective. An operator can do the work itself, and just make sure that you get the right security settings properly set in your orchestration system. So let's talk how the journey looks like. In the analysis phase, in the application analysis portion, our journey with apt2container is to identify the number of applications with a possible modernization opportunity and the information on that application server. And we use that application server to actually understand the source host. We also learn about the application code framework and the underlying operating system. We actually collect the base operating system information and make sure that we actually can move that to a more efficient and even updated version of your operating system, and I'll show it in our demo. We also collect different environment variables used by the source application and the connectivity settings, such as application port used. The analysis phase provides us with the first indication on the opportunity to containerize the application. Once we finish with the analysis, we move to the transform phase. In the transform phase, apt2container collects all the needed information from the source server and creates deployment artifacts. apt2container provides a complete, editable applications inventory, so the operator is able to edit the inventories file and decide which application she or he would like to continue with and modernize the process. Once the inventory information is complete and includes only the applications that are required to be transformed, apt2container will extract the binaries from the application server and then modernize it. apt2container brings the required base images from either ECR or any other repository that you need. And in most cases, it will be a Windows-based image from MSR or a Linux-based image like Amazon Linux. However, users can actually provide their own base images if they want to custom the container to create their own likening of base image. Then we get to the transforms phase. What App2 Container will do, will actually create deployment automation artifacts that you can take those artifacts and put it into your CI/CD pipelines or any type of other automation that you have in order to deploy the application into your EKS, ECS, AWS Fargate, or App Runner. So let's look how we operate App2 Container for both Java and .NET applications. Our source application can be deployed on any infrastructure you are currently running your application on. We have no preferences. You can be on a virtual machine somewhere, on-premises server, Amazon EC2, or any other infrastructure out there in the world. App2 Container will support the modernization of both .NET and Java-based application. And as mentioned, App2 Container will provide the operator with the containerization application and the artifacts required to automate and manage the deployment of the modernized application. We're also going to put a container into ECR and create clusters on ECS, EKS, or we will provide a lifecycle management tooling. If you are using any type of pipeline, be it Cloud Build, Jenkins, or Azure DevOps, we provide you with templates to take the application that you just containerized and use those tools to deploy into our infrastructure. Let's start containerizing an application. I have on the left side a Microsoft IIS server. This specific server has 6 websites on it. I will install and create a remote host. Think about it as Bastion server that will be able to create all the containerization, all the processing of extracting, analyzing, and getting the information from my server without burdening my server with the workloads. So what I'm going to do first, I'm going to actually ask for the inventory that exists on the remote server. I'm going to get back a file that's called inventory.json. That inventory.json will include all the applications that I have in that specific server. I will have the name of the application, in this case, site A, the networking, what's the binding outside world to look at it, what type of application it is, and so forth. Once I have inventory of all my applications, what I'm going to do, I'm actually going to analyze that specific application. So the analysis phase is created or executed application by application on my server. I'll get back from the analysis part a more detailed information about my application. I will get, for example, what is my framework that I'm using, what's the base server information, what's the image tag that I want to use, and other information on the included files, web applications that are part of that specific application as well. So I will have a full picture of my applications before I start to actually extract the information. So now I have a full analysis of my application, and I can move to the next phase. I can actually go and extract the information from my server. My server is continuing to work, as nothing prevents from accessing the information and the application that's running on the server itself. Once I extract, I will get the zip file. This zip file, look at the name, is actually identical to the application name that we are containerizing. And I will contain all the different packages, DLLs, base image information, binaries, anything that I need to actually operate the application within a specific container. Once I extracted the binary, I'm going to go and containerize that specific application. So the containerization process is not created or not done on my Microsoft IIS server. It is carried on my remote host. There are several benefits to that operation. One, everything is centralized and done from a single station, and I'm not overloading my Microsoft or my application server, which can continue to serve my customers. I will also get, after containerizing, I'm going to get the deployment JSON. The deployment JSON will have information about how do I deploy this application and where to, and the different bindings that we spoke about. For example, the networking information, base images that I need to put, and everything else. Once I have that information, I can actually now completely disconnect myself from my application server. My application server, as I said before, continues to run. But now I'm going to go and start deploying the application that I extracted. And remember, I didn't open an IDE. I didn't look at the code of the application. I didn't look even on the configuration of the application, how it is being deployed on that specific server. All I did, I ran 4 commands, and I have my application containerized in my host worker. The next thing that I need to do is actually start deploying the application to a better orchestration system. So I'm going to create the actual deployment system. And I'm also going to create a pipeline. So if I'm using any CI/CD pipeline, as Tom mentioned, I have a blue-green system. I will get the template to use those pipeline systems, Cloud Build, Jenkins, or Azure DevOps, to actually deploy my application using that pipeline. So anytime I'm going to, let's say, make a change in my configuration file, I immediately going to push that change and trickle down to a new deployment of my application on the servers, on my containerized system. So what's going to happen now when I actually generate the application? A couple of things going to happen. The first thing, I'm going to create an ECS task, which means the task it's actual deployment of those applications as a full application to ECS in this case. I will get the full AWS CloudFormation. So think about it as an automation to deploy, manage any type of infrastructure that you have on your cloud system. And anytime I'm going to actually be able to ignite that CloudFormation in order to create additional orchestration should I need to. And the most important, I'm going to take this container that I just containerized and push it to ECR. Now I can take that specific container, be it Windows application, Linux application, and deploy it anywhere I want. No longer I need my host server, and I can deploy it as many times as I want, as long as I have it on the ECR and I have the URI to get to that specific ECR. Once I created my deployment, the next thing that I'm going to do is actually create the pipeline to actually control the different activities that happens on my configuration files, maybe even the application. If I have access to the source code, you can use the same pipeline and commit a change to the code, and it's automatically going to deploy it back to the ECS cluster in this specific case. So let's talk about where we recommend to use app-to-container. Definitely web application and web servers. We see an amazing benefit there. It's a very easy, as Tom mentioned before, we see a lot of 1-to-1 ratio, and it makes a lot of sense to take those web applications that somebody created 10, 15 years ago and move them to a more efficient infrastructure. Any type of middleware that you have, think about .NET Framework and Java application that you created, an excellent use case. If you have a multi-tier stack, again, excellent use case from our perspective. Think about a very low type of application that is always on. Containers are amazing deployment platform for those systems. And with that, I'm going to move to the demo. We'll have two servers. We'll have a web server which has the actual application on top of it, and the database server which uses the web app actually used to get the resources and information. If we look how it looks like from the application itself, we see that we have on our .NET server, we'll have our application which is running. It's a simple application we call Unicorn, has its own blog. My application up and running. I'll have a shell open here, and I have installed here apt-container, and we'll initialize apt-container. Oh, sorry, this is the command that you can use. And let's initialize it. We'll place the information inside this remote host, and I will use the user profile that we created. This is our US West 2. Yes, I did create an S3 bucket to store any artifacts that I need to use. So that the name of that S3 bucket is A2C demo, and will help with debugging and initialization. We will not sign our containers. We can configure our remote host connectivity. Since we are connecting from a remote host to the actual application server, we need to provide credentials to do that. We'll need to provide the IP address. And we'll need to provide our information about accessing the username and password for this specific server. And we don't want to configure additional server. We'll do just one, but if you do have multiple servers, you can actually add additional remote host to the configuration itself. So apt-container can connect to those remote servers one after the other. And with that, we configured our remote host. And as we have our remote host configured, the next thing we're going to do, we're going to actually look for the inventory on that specific host. And that we'll do with the following command: apt-container remote inventory, and our target, the IP address already. And now apt-container connects to the server and is copying all the information from our remote server. Great, we have the inventory completed on our side. If we actually want to see how this information looks like in this specific server, we'll go to our app data. So let's go to administrator, app data, local, and our remote server. We see that we have one server here and this server, and we have a file called inventory. If we open it, what we'll see, as we showed in the presentation, we'll see the IIS default website. It's a default website and it's port 8081, and we know it's an IIS based application. Now I need to continue the understanding of what's in the server. So we'll just take this information because we need it for the next part, which is the analysis part that we're doing for the that specific server. So we'll do app to container, remote analyze, and we have taken the application ID to continue the process, and our target server IP address, okay, is 10.0.0.146, and this is where app to container will connect again to the server and start analyzing that specific application. And the extraction and the analysis has finished. As I said, I'll cut off a little bit of the video in order to make sure that it's not too long, because the process takes time. And then we'll get a JSON file that includes the analysis. We'll go back to our browser. And this is our analysis file. What you'll see here is gets the information about the actual application. It understands also what is the base image that uses in that specific application. And there are parts that you can edit inside this file. And there are parts which stay completely stationary and you cannot move them off. You can define different capabilities and versioning of your application in order to make it more customizable for your own usage, and if you need to provide any additional information about the ports, and if you have to include any specific files inside your application. The next thing we're going to do, we're going to actually extract the information from our server. And the extraction starts. At this point, app to container connects to the server and pulls in all the binary information from the application server and brings it into the remote host. And now that the extraction has completed, we'll actually have the artifacts of that extraction included in our own server. There's going to be a zip file with the whole application stored here. The nice thing about it, you have the next steps, and now we're actually going to containerize our application. Again, this process can take time, so we'll let it run. And now the containerization has completed. And the first thing we're going to do, we're going to look at the Docker images that we have here. What you'll see, couple of things, two things. If you remember, the initial server that we used, the actual web server, has Windows 2012. Here what happened is actually because we are containerizing the application on a server that is 2019, it will take the base image of the remote server to create the actual container. So two things happened here. One, we containerized the application, and second, we were able to change the base image from 2012, which is no longer supported, to a supported version of Windows. That's a twofold activity that we get from here. The next thing we have is the actual deployment JSON file, and let's give a small look into that one. And here we have the actual deployment of our application. What you'll see here is that there are different capabilities that we can provide. First thing is we can decide if we want to have the installation based on ECS or EKS. In our case, will default into the ECS information, so we'll deploy our containers into ECS. And the next thing we're going to do, we're actually going to have to add our VPC information into the file itself. And we have our VPC information. We'll add it over here. And as you can see, we are creating artifacts for ECS. Now, if you want to deploy into EKS, for example, you'll go back to the file and create artifacts for EKS, set the deployment for EKS to true, and the deployment to ECS to false. And this is how you'll get the application deployed into EKS. That's the idea. We'll save the file. And we'll exit. And now that we generated our deployment artifacts, we know that we can find those artifacts in our ECR registry, and we can actually go and see the different artifacts that the apt container created in our A2C demo that exists on our S3 bucket. We can go ahead and immediately deploy if we want to do that with CloudFormation. The actual command to do that is available here as an output from apt container after he generated the deployment artifacts. We will look first on our ECR registry to see that we have the container and the information about that specific container. And if you're looking at our ECR registry, we can find out that there is a container that was created today. Going inside of it, I can actually see the information. It says latest. That's exactly what I was expecting. If we're going to create additional versions, then we'll see that there are different versions on the actual container. I can actually copy the URI if I want to tag that specific information to my deployment procedures. I can tag that URI and implement that one and have multiple deployment of the same container. Our ECR registry all open, and we have defined our ECS cluster properly. Let's go and deploy our stack. At this point, there's a creation of our ECS cluster and the deployment of our different artifacts into ECS. Deploy has completed. Now, two things happen. One, we have an ECR cluster, and we'll show it in a second, and also an ECS task. An ECS cluster and ECS task. So now our application is actually deployed. So let's go ahead and find out exactly where it is deployed. And now we have our ECS cluster up and running. We can go and look at it, but before I do that, let me go back to my S3 bucket. For each application, apt container will create an ECS artifact list. And those artifacts are available for you if you want to actually deploy a different ECS cluster or to this specific cluster and change any of the configuration file, for example, access, load balancer information, and so on and so forth. We'll go back to ECS. We'll go back to our cluster. The next thing we want to do is actually find out where is the application deployed and access the application. So what we'll do, we'll go to the load balancer. It will open an additional information, and let's select our load balancer, and this is the information, and this is the DNS name. So we'll take the DNS name and we'll copy it, and we'll go back to our browser and launch our new website. And now that I have the new website URI, I'm going to take it, deploy it in my browser, and access the same website that I had running on my ECS server, on my EC2 server into ECS cluster, up and running as a container. It's easier for me to manage through ECS change the different settings of the application itself, scale it up, scale it down based on my needs and my customers' requirements. And this is how we help our customers move from on-premise or EC2 Windows servers into an ECS-based container, Windows container. Multiple benefit, as we have just mentioned. You reduce the number of Windows licenses you need because now this is a container, so you spend only on the host server license, so you can run multiple applications on a single host through a containerization. You take app to container, modernize your .NET and or Java application, transfer them into ECS or EKS and UpRunner, and have the same application with no changes of code. I didn't change a single line of the code of the application itself. It's a .NET application. I didn't open any IDE and just modernize the application. Helps you also to take the advantage of operators can do that without any intervention from either code developers or code architects. So the application architects and the application developers do not need to be involved in most of the procedures to move your application from an EC2 based instance to ECS or EKS. And now that we have completed our application deployment, let's create a pipeline, a CI/CD pipeline. So any changes we're going to make in any type of configuration or source code, we will be able to take that, create a commit to our, for example, Git repository, and initiate a pipeline creation. The first thing we're going to do, we're going to create the pipeline artifacts with the app to container. And we got our pipeline created. Let's go and look at the different artifacts that were created in this process. In the pipeline information, there's a file called pipeline. What I did here prior to that invoking of that different pipeline information, I placed the cluster name that I've created, our ECS cluster, and the service information that exists as well. Just verified also that the name of the repository is correct, and we're going to be using code commit. We also support Git operations as well as Azure DevOps capabilities. So if you are using any of those tools, you can continue and use those deployment tools together with the template that we provided here. From that perspective, if you can go down to enable that, you'll enable Jenkins by setting here true and or Azure DevOps through here. I'm using AWS code pipeline to deploy our cluster. Additional information that is available here. If you look at the artifacts, those are for the pipeline itself. So I'm looking at the build spec, just making sure that I have all the right information in terms of the bucket information, different repos that are going to be created, and so on and so forth. And that's the actual file of deployment. It's going to create the different Git repositories and the Git commit on the code, the Git on the code commit site that we have in our developers tool at AWS. Pipeline stack has been deployed with the CloudFormation. The stack itself is created. Let's go ahead and look at that specific stack on our web browser. And now we can see that we have our pipeline under code pipeline at Amazon developer tools. We're gonna see we have pushed the code, new code here, and right now the application is being built. This process is going to take a while. It can take a few minutes, even 15 to 20 minutes to create that build. We'll pause the demo here right now and come back when the actual deployment is created. I just want to show you one more thing. The actual pipeline creates a bucket for all the artifacts that are created through the build itself. It's created in our S3 bucket here in this case, and you can see all the different artifacts that exist here for your actual deployment. We'll come back to our code pipeline in the minute that the build is completed. And great, we can see that the build has completed as well. And the next thing that's actually happening right now is that our cluster gets the new update and the new production deployment that we created. We changed some information in the build file, and it immediately created the pipeline. As you can see, source code has changed, build created. We pushed a new version and committed a new version. The build has happened, and now at this point we take the artifacts and they're being pushed into our ECS cluster. We'll wait for the actual deployment of the container, the new container of the same application to happen on our ECS cluster for a second. Let's see if it finishes in time. If not, we'll pause it and come back to the demo again. Let's give it a second. Meanwhile, we can actually go to our ECS cluster. Let's refresh here. This is the log of everything that happens in our deployment. As you can see right now, we have one active and one primary that is being pushed, so this pending. At this point, the actual push of the new image and the new container that we created with our build is being pushed to our cluster. That's the process. Let's see, it's still happening. At a certain point, there's going to be a change. This is revision 2, and now revision 3 is waiting to actually become active. We'll give it a second. This is our cluster, the service that we're using. Let's see our code pipeline information. Still building and creating our artifacts. And the release also to production completed. We have done the change, the build, the release. Let's go to our cluster. Let's refresh our deployments, and we see that there is no longer the previous version. We have revision 3. Our revision 2 has been decommissioned. As you can see, we had one task coming in and deployed a new container based on our new build. So we show there are useful resources on our website, so feel free to use them. And with that, I want to thank you for attending this demo and this presentation. Back to you, Nidhi.
All right. Thank you so much. Thanks for covering up the demo and great topic of discussion. Thank you very much. And I think before we conclude, we have some Q&A, as well as Ashish want to show some of the workshop that he was mentioning in his session. But before we conclude, I would like to thank you everyone for attending the webinar, and the recording of this session will be available in a few days. So please look out for the email that will come from our email address to get an access to the video recording for the session. And as I mentioned earlier, there will be be a survey request sent out to you by email also. It will take only a couple of minutes for you to please fill it out. It helps us to improve the performance and the quality of these webinars and even the topic to choose from going forward. So please feel free to fill up the survey questions to help us on that. And I would share with you the email address that's already on the last thank you slide. But before we go into that, I will pass it on to Ashish because he mentioned about some of the self-help workshop for ECS and EKS. So go ahead, Ashish, and please share that. And then we can look up the Q&A questions.
Great, thank you, Nidhi, and thank you, Yael, for the great demo. So hello, everyone. I think during my session, we talked about how do you take advantage of the AWS container orchestration service to run your .NET workloads? So based on our experiences with different customers across the industry, we have created this workshop, which allows you to run your sample .NET workload on the two most popular orchestration engine, that is EKS as well as ECS. We ran the same workshop at reInvent 2022, and it was well received. It does cover some of the common patterns that we see our .NET customers struggling with. So to give you some perspective, during my session, I talk about persistent storage. What does that mean? If you actually have a .NET application that needs to store some data for further processing, how do you go about doing this? In a traditional model, you can actually have access to, let's say, a file share on your web server. But with containers, you lose that privilege. So we do have a separate module that covers as to how you can go about using it, both on EKS as well as for ECS right here. So there's a separate lab for that. The other aspect that comes very often during our discussion, if I'm running a .NET container and I need to go and talk to my SQL Server, I want to use Windows authentication because that's the security model I'm using on-prem. Now, when you go to the container, it does pose a challenge because you do not want to join your host instances to the domain for performance reasons. Now, how do you go about implementing a concept like GMSA, which stands for Group Managed Service Account? So we do have a separate module I would like to bring to your attention. It's called Integrating with AD. And this is where we actually walk you through the steps on how do you integrate GMSA with EKS and with SQL Server. Similar concept applies on ECS, and here's a lab for ECS too. In addition, I know Yael mentioned that you can actually take advantage of App2Container. That's a tool or an accelerator to help jumpstart the containerization process. But at the same time, if you would like to manually go and spin up a cluster, EKS cluster, then we do actually provide scripts here on how to go about setting it up. It does give you visibility in terms of different tools that you need to use to provision and administer your infrastructure. The tools that are actually here are called EKSCTL. This is a command line tool, kubectl, which is an open source tool, along with AWS CLI. It does actually give you instructions on how to enable Windows support for Kubernetes. So when you spin up a Kubernetes cluster, there is a specific configuration that you need to apply to enable Windows support. And once you have that, you can actually run your Windows container on Kubernetes, right? The link for this has been pasted in the chat window. And I think when we send this recording, we'll be happy to share this link again with you guys too. All right, Nidhi, I'd like to hand it over to you now.
Thank you so much. So I would like to conclude by saying thank you. And I think we have some Q&A sessions. So I will call Runeet to help us address any Q&A that we have. And we will stay online. So if you have any questions and you would like to come on the mic to ask a question to our specialist here, please feel free to do so. I've also listed out the email address, which is awsmodgtm@amazon.com. So if you think of any questions afterwards also, please feel free to drop us an email for any questions you may have, and we can address that later on. You have the list of the speakers here with their social media profile. So please feel free to reach out to any of us, and we'd greatly appreciate you joining in. So I'll pass it on to Runeet to answer any unaddressed question. We have been answering questions on the chat, but we will address any questions that has not been answered. And if you have any questions that you would like to discuss with our experts, please feel free to come on the microphone and feel free to ask that. So to you, Runeet, do you see any questions?
Sure. Yeah, Nidhi, I think as of now, we were able to answer most of the questions that were posted in the Q&A panel, but since we have a few minutes, if anybody has any questions that were not answered or they didn't get a chance to ask, we can use next few minutes. Or if you want to reach out to us offline, drop a line on that email address, which is AWS mod GTM, and we will surely get back to you.